Hey guys, and welcome back to another video. We'll talk about MLR4 and the intuition behind a regression, how we actually should see it. So let's start with the 5 MLR assumptions. OLS is blue under these 5 assumptions. What are these 5 assumptions? We'll talk about it. Firstly, blue means best linear unbiased estimator. This is the Gauss-Markov theorem. And okay, MLR1, linear in parameters, y is xb plus u in the matrix form. Okay, so I have a question for you already. Is this linear? Does this violate MLR1? 3, 2, 1. Okay, this doesn't violate MLR1. So this is actually okay. Why? X squared is related to y linearly by b2. So it is linear in parameters and we can regress this. And people actually do it quite often. So don't get tricked. MLR2, random sampling. What's this for? Independence. Observations are independent, so you're not all taking from one village, for example. MLR3, no perfect collinearity. X1 or whatever, x2 cannot be a linear combination of other regressors. So you cannot have x1 equals to x2 times 2 or something. Cannot. MLR5, variance is constant. Homoskedasticity is a hard word to pronounce. Homoskedasticity just means that sigma is constant and u has a constant error for any x. Now let's talk about MLR4. Zero conditional mean of error terms. So you want E, expectations of u on x to be 0. What does this mean in practice? Okay, let's do an example. Y equals to beta 0 plus beta 1 x1 plus u. Let's say y is wages, a classic example. X1 is education. As education goes up, wages go up, right? Yeah. So let's say U contains something like ability. What happens? What does ability affect? Think about it. Ability means you're smarter, means maybe you want to go to school more or you get more education and you earn more. So ability affects education, which affects wages. And ability also affects wages, right? So we will call this a confounder. Anyways, we call this in general OVB, omitted variable bias. Ability affects education as well, and we did not control for ability. It is in our error term. Since correlation of ability and education is not 0, the expectation of u on some level of education is not 0, right? Because let's say high education has high ability, then your correlation is positive. Your expectation of u given a higher x is higher than 0. So we cannot, well, OLS doesn't give us blue. Makes sense? Does OLS still work? Do you know the answer? Yes, it still works. Why? OLS is just a mathematical, minimize the sum of ui squared. So no matter what the assumptions are, OLS will give us mathematically correct. However, can you trust it? Can you trust it for inference? No. Inference can be hypothesis testing, confidence interval. We'll talk about that in another chapter, in another video. So if not satisfied, does OLS still work? Yeah, it does. we will move on to the second part of the video, which is very important. How should we visualize this in our head? It's a matrix, and this is the vector. Let's just do 2. Okay, how do we visualize this? Okay, let's say we want to model test score, once again, like the previous video. This is the score if you do nothing, or well, if x1 and x2 are nothing, right? So let's say x1 is again our studied. What's another thing that could affect your score? Let's just say your IQ ability, right? So what is the intuition of regressors? What are these things? We're actually trying to say, what can y be explained by? What can y be explained by? What can our test score be explained by? It can be explained by our hours studied. The more you study, the higher your score. Or well, they're associated with each other. What's another thing that could affect your score? Maybe your talent, maybe ability, your IQ, just in general, how smart you are. So this can go on, right? x1, x2, x3, x4. But we don't have x3 and x4 here. So what is U? U contains everything else. Everything else that we haven't modeled. That affects our score. So U actually contains x3. We can call it x3 or x4 or whatever. U contains, let's say, sleep. If you sleep more, you get a higher score. Maybe, who knows? So what is a regression? We're trying to model as many x, so-called factors, as possible to explain our y. And this idea is called R squared. What is explained by regressors intuitively? So in a perfect world where R squared is 1, you actually have this, right? You have explained every single factor that can affect your score. Super ideal world, but this is impossible. Plus beta, whatever, 100, x 100, who knows? This is impossible. So this is something you should know, how to see a regression. It is not key to the assumptions that we talked about earlier, but it is how you're supposed to think about the U term, which wasn't made very explicitly in my education, so I hope this helps. So that's it for this video. Thanks for watching. Do subscribe for more and leave any questions you have in the comments below. Thanks for watching.